Alright, on the bench today, an HP 3968. And that's an instrumentation recorder, and that's because we couldn't find the Apollo one. So the Apollo spacecraft had an in-flight recorder, which is absolutely gorgeous. We could find some, but not one that would be known to us. So instead, we're going to do the next best thing. We're going to do an HP one. I think it has 8 channels, and you can either record directly, or you can record an FM signal, which is actually a tone. Some have FM and some don't have FMs, and I'm wondering if it's a set of cards that you change. Reals, not original, bought them on eBay. Alright, well, we're going to figure that out. Hello and welcome back. If you follow the channel, you know that we are restoring the Apollo electronics. The communication setup, which we have nearly completed, included a data recorder called the data storage equipment. It had 11 tracks and could record and play back at 3 different speeds. This HP unit is our next best bet. There are 2 models, the 3964 with 4 tracks and the 3968 with 8 tracks. Both had 6 speeds. For each track you can use either direct recording, the traditional analog recording, or FM recording. FM was the most common option as it covered DC and was much more accurate for data up to 5 kHz. Direct recording was used for voice or anything that required high bandwidth, as the HP unit went to an impressive 64 kHz, but no DC. The lower limit in that mode was 100 Hz. You switch from one to the other by physically replacing the channel cards. For our Apollo setup, which is voice and high-speed data, we prefer direct recording. This unit seems to have 4 FM and 4 direct cards, but we'll soon see that it's not quite what it all appears. And we have already spotted our first problem, which we were sort of expecting, is that the capstan is dead. And the capstan wheel is over here. And it's gooey. It's not that gooey actually, but it's broken up. So at this point I don't know it yet, but this is actually not the capstan. This is the pinch roller that forces the tape against the capstan. The capstan proper is hidden above the pinch roller and is made out of a ceramic material which is very durable. Nevertheless, we'll need to replace the roller. Let's open this up. Alright, big reveal. Okay, wrong way to open it. We just open and then we'll figure out what happened later. Alright, pull out. Revealing spiders!
And a lot of spiders.
You know what? Lots of spiders, but no rust.
That was either a very large spider or a very small mouse.
Should we see the spiders on the other side first?
Yeah, why not?
These are rare. Alright.
These interchangeable.
It looks like it.
Looks like a moth. Right?
Oh, yeah. Ah. So yes, that's why it might have been why it was open. Somebody might have harvested a transistor. Either that or it's an option. There we go. Okay, try. No.
This is a screw.
Should we just read the instructions?
Nah.
They don't actually tell you.
There you
They
go.
show the screws. Ooh.
Ooh.
Ooh, cute little speaker.
Oh, they have labels underneath.
Okay, yeah, you have a speaker because there's one of the tracks you can use to record a commentary to it. And there's also one track that you can use as a reference for taking the wow out. Indeed, there are a couple of special tracks. Track 8 is the one that is monitored by the speaker and can be used to record voice comments in between the data takes. Track 5 can be used to record a frequency reference, which is then used for automatic flutter compensation during replay. That is quite useful if you work in a vibration-rich environment, say a rocket, for example. There are some FM cards and there are some direct cards. For the Apollo system, we'll need the direct, I think. We'll just direct record. Oh, that's fiberglass. That's not metal. That's why it broke.
It should just hinge right out. Ooh.
Wow.
Nice. Wait, danger. Unsupported recorder will tip forward if
Yeah,
transport is swung open.
I just noticed that. Okay, so I need something underneath here. Okay, hold on a second. We supported it with good HP batteries from another instrument we're repairing.
Is that the capstan motor that's the giant one?
I think so.
Yeah. Lots of mechanical gizmos. Some relays. Hard to see what this is here. What is that?
What's the big solenoid for?
Yeah.
Brake or something.
Rewind? Yeah, brake. It's a brake. I can see the brake actually, visually. That is just dead, so we need a new band.
I think that's just for the counter though, so it's not really critical.
Oh yeah, you're right, it's a counter. So Ken found out what I thought the clutches were.
So it's left wheel motor and right wheel motor.
Okay. So you have two real pancake motors. Huh.
They go like different directions for forward, reverse, fast forward, fast reverse.
And I think they just put tension, right? They're kind of weak motors and the capstan does all the work.
The capstan motor has a tachometer, so there's a servo loop to get the speed accurate, and crystal oscillator.
These are actually an active loop tension, so those are sensing. There, I see sensor thingies. Not bad. Getting the manual would prove extremely difficult, but we eventually did it. And it looks like we identified the transport parts correctly.
Yeah, there's a lot of interesting options you can get. FM, direct record, connectors in the back, locking knobs. You can get it in metric. The HPIB interface, white paint option to match an environment such as medical facilities. If you go into your doctor, you don't want to see a tape unit that's this color.
No orange, no good. What is the division that make instrumentation tape drive? Dunborn? They made instrumentation tape drives, and you actually find them in the Mercury program. It's huge, and HP bought them. Sanborn. Indeed, Sanborn was bought by HP in 1961. They were famous for their instrument recorders used in medical applications and in the space program. Behold the 7708A. You can spot one right behind Armstrong being suited up, likely to monitor his vital signs. But HP Sanborn also introduced the Series 3900 tape drive recorders in 1965, huge monsters that could record up to 250 kHz. Heck, you could record the whole AM band and replay it later into a radio receiver. It looks like our tape recorder is a descendant of its illustrious gigantic predecessors.
They say this weighs 69 pounds. One pound per track.
Oh, those are heavy tracks. Can you figure out on the power supply if we're missing transistor, or if it's just an option and we don't have it?
Well, there is an option for a 12 volt or 24 volt DC, so it could be that.
And it was indeed that. The missing transistors in the power supply are just part of the battery power option, which we don't have. We don't have the HPIB option on this instrument either.
So that's where your HPIB would go, and then that's just generic remote control.
Actually, generic remote control is going to be more useful to us. Okay, so
Yeah,
we
just wire it
might
up.
be okay. The one thing I would like to do is remove this guy, because first it's broken and second it's in our way. Okay, we got that one. It's actually fiberglass, and there's been some bad repairs that we'll have to clean up, but nothing catastrophic though.
So it says FM on the knob. If it doesn't say FM on the button.
Uh-oh.
What?
They're like opposites.
Each board out here has a little matching sticker, so you can take them all out and put them back
Yeah,
exactly at the
sounds
same place. There you go.
Oh. Oh, it's got a diagram on the back.
And this says FM.
There you go.
And this one
Yeah, then we can...
wait,
FM.
also says FM.
What? Are they the same?
They look the same.
So it's all FM?
Yeah. They say FM record reproduce. And they have a nice diagram of everything.
Yeah. So, dang, it's all FM. So this is the... Wow, this is so complicated.
Voice board.
Yeah?
Yes.
I see tantalums with no electrolytic, so we might be in good shape.
Yeah. Oh yeah, these are all the glass sealed tan ones, so we're probably okay.
So Eric is wrenching the capacitors out. First cap, sprig. Yeah,
Don't be vague.
yeah.
Specify
So this
spray.
way, exactly. It's going to be good. Right, so here's the cap with my new Kelvin clips from Amazon. And it's supposed to be 13 millifarads and it's 14 millifarads. And these are rated 25 volt DC. Will be interesting. And here we have 25 volts applied on it. It hasn't moved a bit. Those switches are absolutely notorious for not surviving very well. And the first switch test is good, but this one is like all over the place. 200 ohms. 0.6 ohms. Nothing. Same as in the voltmeter. You
And
have.
then what I usually do is I'll go in with a Q-tip.
Yep. There's no way around it. You have to clean every single one of them. This is yet another variation of the push button switches that look good but are very bad. We encountered them previously in our scopes and DVMs. You have to take every single one apart and clean them without losing the tiny springs, hopefully. Alright, so we cleaned all the switches and we only had, what is it, 3 flying spring events. We found them all back. And now, 0.032 ohms, and all the contacts are good, so made a difference. And I had Rob help me with all the contact cleaning. And you beat me. You only had one spring flying, and I had 2. So
Yeah.
Okay, well, we put all the cards back. All right. Hard to see, but the heads look like they're in pretty good shape to me. Yeah, I'm not picking up any bad stuff. This is super clean in there. I kid you not, our degausser failed. Everything fails in this lab. And there's only 2 parts in it. There's a transformer and a diode, and the diode quit. All right, well, repair within a repair. I think we have it. We can degauss stuff again. Andy Mag.
Good idea.
I don't know, those could fail. Okay, it goes 60 hertz. I hear it. All right, so I can get in there. And then anything else they wanted to degauss? No, just the guides, and that's it, the capstan. All right. All right. Nothing.
That was not very dramatic.
No. Feels good. Well, that didn't work too well. Nothing. I had some life at some point. Okay. No more. When I want to demonstrate for the camera, for the slightest moment, I had a little thing going on. Okay, we got the switch. In the schematics, they indicate just 2 poles, 4 wires, and I have 7 wires. So I'm utterly confused. Alright, the plot thickens, and in order to see how the wiring was going, I removed, no, not this one. This power regulator card was in here. and I discovered there was a botch repair in there, in the power supply. So those green connectors, they split. What they tried is to bring it all back together. So that might have something to do with our problem.
Yeah. Gross.
Okay. And it looks like I have one in my collection with ears, but we can always shave the ears. So we have to replace this, which is going to be interesting. Oh, same repair on the other side.
Oh boy.
You can see that they had the same problem and repair.
Moments later.
And here you can see our very cracked connector is cracked through the bottom and through here.
More moments later.
And the new switch is in on the side after a tough battle. And I checked the switch, and the switch is good actually. So same problem on this side. Yeah, it's all broken and bowed out. Okay, got that. Yeah, it's not. It was not going to make any contact. Connector is in, so two bad connectors out, two good connectors in. Is the connector a different thickness? So the boards are hitting the ears and it doesn't go in. It was so hard to solder in, I can't desolder it, so I'm going to just hack at it. Why do this connector break when you don't want it? It don't break when you want. There you go. Yeah, try number 2. Alright, that worked a lot better. Why is everything fighting me so hard today? Alright, so I have to file each end here a little bit too. Ah, there you go. Alright, okay, so we're back. Aha! Aha, that was it. There you go.
Ooh.
Ah. Okay, I missed the slide, but I have a box of it. Stop. Ooh. Ooh. Okay, I missed the slide too. Oh, there you go, it came back. So I found the bulbs. They are E85 bulbs. Here we go. Once you know what it is, E85, 24 volts. If I can do it while showing the camera. That's how it works. Clean that already. You can see that's all yellow, so that's the one they used the most before. Yeah, 3/4. Okay, next thing we got to do is replace our little tape roller. Has been remade by a local guy in South San Francisco that does it for audio tape desks. I got it. Okay, got it. You can see it has been glued all around. And here's the professionally made new one. That's it, new roller.
And we were about to try it when this happened.
And surprise, we have 2 of those things because we got one more thanks to John Pumpkinhead. His has something that we would need for the Apollo setup, which is the different card. It's a direct write. You had redone the capstan for it, right?
Yes, that's correct.
You lent it to me too, as we're always generous, so it's over there, which means that yours is capstanless, right?
Correct.
But yours also has an option that I don't have. At least it has 2 options I don't have. First, it's a 4-channel instead of an 8-channel, which has some advantages, higher performing actually, because the heads are bigger. But yours has the HPIB, which you can't see, it's underneath here. HPIB over there. And you have inputs and outputs in the back. So you haven't checked anything?
I've never touched. You've gone farther than I have.
Okay. Well, yours works a lot better than ours. Switches do work. And I think you do this. Yep, you do that. And then... you know what? It works. But before we continue on with the new 4-channel unit, since John had brought a whole box of all new tapes, we decided to thread the 8-channel one and give the tape transport its first real test. Alright, so John also came with tapes. He has everything. Ooh, they're very chocolatey. Alright, and then start.
Okay. There we go.
The slowest speed is fast.
That's not good. No, stop. Okay, so it's not. We need to adjust the.
Tack, servo, tack or tape?
Well, it should be tack. And it is, but the light's not lit.
Just then.
So, while I was looking at something else, John pushed the button and now it works. So, you have a competition, Eric. There's another magic finger. And now actually it lights up, right? So
Don't touch that.
I bet you it's that.
Touch it. Yeah, it's probably bad.
And now it does this. Hooray! After a poke of the magic finger, the tape transport appears to work. Another quick check we can do on this FM unit is to mount a standard audio calibration tape and see if we can hear something from channel 8, which is monitored by the internal speaker and should be able to give us back traditional audio.
So what does it say on the front there? 15 inches per second.
Yes. And that's the EQ.
Multi-frequency,
Right.
0 dB, 6 minutes. 6 minimum?
Right. And this is the reference, the standard reference of 250 nanowevers. Which are the direct ones?
I don't have a direct one, so you should just get the voice one.
That's not bad. It's not bad at all.
Fairly close to 0. Right?
Yeah. That one's way off. That one's pretty close. 7 is very close.
We'll show you later how to do a proper channel calibration with the internal calibrator, a major feature of instrumentation recorders. But while we were running the tape, it started to become a bit squeaky. A pretty usual problem if you work with old tapes.
You can hear the squeaky.
So what's the squeakiness going
That's
from?
the sticky.
Sticky tape?
This tape's getting sticky.
Do you want me to bake it for a few hours?
Couldn't hurt.
So the usual remedy is to bake the tape at low temperature for a few hours to reform the binder. And of course we had to completely clean the heads again before attempting another pass. The tape had shed quite a bit. So we're going to do some home cooking of tapes.
You can see back in there if you look.
And this is just a food desiccator.
It's a one-of-a-kind tape.
130 to 140, so we'll do it over here. And trust the Chinese calibration thereof. So while our tapes were cooking, we turned our attention to the other 4-track unit. So while you were not looking, we cleaned the heads, the capstan, temporarily repaired my it's my roller here, which was not as bad as his. Yours was completely decomposed, right? And I put electrical tape around it, kind of smooth it up, should be enough for a temporary try. Oh, it's very slow when it goes forward. Okay.
See?
We can see if it
starts getting into trouble.
Okay, good so far. It looks very smooth. This one regulates smack in the middle where this one didn't. Yeah, I can see the servo tension doing it. We might have 2 working tapes.
Several days later.
Alright, we are making some progress on the tape. I got the 4-channel one going for a little bit. On this one, the channel 4 is the one where you can do the voice, do some comments, and I couldn't do it until I figured out that the microphone has to be between the outer conductor and the center, and the record switch has to be between those two. So once I made the adapter, it started to work.
Mary had a little lamb, little lamb, little lamb. Mary had a little lamb, its fleece was white as snow.
Alright, I do stop. And where it doesn't work is that reverse doesn't work. But the fast reverse does work. So if I watch quickly, you could hear that it recorded something. Mary had a little lamb, little lamb, little lamb.
Mary had a little lamb, its fleece was white as snow.
Okay, that worked.
Alright, we got 2 units that show promising signs of life and can record some audio on the comment track. But we're still fairly far away from having instrumentation tapes that are fully functional. Transport is not working in reverse direction on the 4-channel unit, and we'll soon discover that the channel is not working on the 8-channel one. That will send us in more adventures than we bargained for in the next episode, but we'll hopefully get to record true multi-channel telemetry by the time we're done. See you then!